just adding the link to Facebook. Right, and we are live, I guess. Anybody out there? Hey Stuart, hey Ped. Good afternoon. Good morning, Ped. Right. Let's see where we're up to. .ods, wasn't it? Load plot test.ods. F10. Go into game mode for the keys. Right. I'm just changing that to paper 2. Just to confirm the fact that the attributes are in the wrong place as of last week, because the best escape. Oh. Right, plot test.ods. Right, as you can see, we print this at 0,24, so 3 characters down, and then we print paper 2 ink 0, and then we print an 8-bit test value, but the attributes were wrong. They're on the load down, the character lower down, and the reason for that is, so character, here we go. The reason for that is because of this bit, because what we did was we did a pixel down 8 times. We could change this to 7 and then add another load A with DE and load HL with A. That might be better actually. Yep. Because what's happening is it's moving down a pixel each time it goes through this little DJ and Z loop. And what happens is when we convert HL to an attribute address, it's actually, you know what, I'll keep it on 8 and then we'll just go up a character row in the attributes. Add HL, comma, minus 32. And this is at HL equal HL minus 32. Moves HL up and correct because we drew the we drew 8 lines of character. Yeah, which meant the HL was now pointing a character lower. So we remove 32 from well, we subtract 32 from HL because that will just take it up 32. Take it back 32 bytes, which is up a character in the attribute RAM. Right, so save that, and then if we exit out of that, assemble and run, our attributes are now in the right place. Yeah, very good. Thank you for reminding me, Stuart, on the what key was it to space to exit, right? So if we edit that, and if we go back up to the top again of the source file, wait for it to go up. .28, just so that the comment matches what the actual code is doing. Right. Hi, Richard. Hey, Tony. Hey, Retro Robbins. Just going through the so back. Yeah, thanks for the comment reminder, Stuart. Hey, Nigel Hurst. Welcome back, Matt Langley. No worries with missing out over Christmas. That's why it's going on to the playlist. So you can go watch them whenever you're ready. Hey, Matteo. Welcome back. Yep, Christian, real-time coding. This is not rehearsed or anything. We're just going to make it up as we go along. If I press on the right screen. Hey guys, Marshall. Right, so for those who have just joined, all we have done is fixed the bit where in the print routine, which printed the attribute in the wrong place. It was a whole character down because let's change that back to b equals 8. It was a whole character down because we print 8 pixel rows, and each time we go down a pixel line, we go a pixel down with HL, which takes us, after 8 times, we're in the character row below. And what we did here was we got the address of HL and converted that to a screen address. It actually you know what? That might cause an issue if we go off, because we will. No, we might be able to. Let me just check. I'm going to check. I was wondering if, because it goes down a pixel, when it will on the bottom row, it will go into attributes. So I was wondering if the conversion will still work when we convert from the screen address to attribute address. So the way we can do that is do 192 minus 8, and that we could do 184. Save that, and then assemble and run. And yeah, attributes in the right place, so we can just do the minus 32 with HL. Right. So if we put that back to 32, so it's 24. Save that. Get back to our routine. So basically all I added was this add HL comma minus 32, which takes HL back up a character once we've back up a line once we've made it point to the attributes. As you can see from the comment here, moves HL up a character because we drew 8 lines of character, which meant HL is now pointing to a character lower. Yeah, it could also pop, but it's quicker to do an add HL comma minus 32 than a push and a pop. That was the reason for the add HL minus 32. Right. Wrong one. So right, what I'm going to do now is we'll show you how to add more more things. We'll get that more stuff on the screen. Actually, we shall define them first. This file's getting big. Is the audio all right, by the way? Is it clear enough? Can you hear the noise of the fan? Audio's good. Okay, cool. Right. Right. Enemy, or we'll call them characters. Character data. Again, indexes. Right. Actually, I would call it character structure. character structure. Right, so I have call it CHR underscore expos. Actually, call it 3 character action EQ 0 CHR action table EQ1, 2 bytes long because this is going to be a pointer. YPOS EQ4. Right, we're only going to do 8-bit for now, for the X and Y. Right, what else can we do? See, got type EQ5 info1 call it info1, call it data1 EQ6 CHR data2 EQ7. You okay following? I'm not going too fast, by the way. I'm trying to keep it slow, so it's depending on different people's typing speeds, and having to remember shift and control 0 for underscore. EQ9. Actually, what I will do is I will just give it data, and then I will just delete these lines, and then we can add CHR data +1, etc. And then we can have anim EQ CHR data +8 and then CHR frame EQ I should do this really. No, I'll 14 because then 14, 15. That'll do, and then CHR size 16. So 16 is the size of array. That works out okay for now, and we'll just use that for now. Right. Okay, I'll put the comments in now. Right. Actually, it might be best for me to put these anim and frame before data. Copy. Paste. Copy. Paste. Six. 7. Right. Depending on what kind of game you're doing and what kind of things you want to add to it, this doesn't have to be exactly like this. This is just this way because that's how many bits of data I'm going to be showing you how to use with your characters. And the data is, actually we call it MISC, as it's miscellaneous stuff, because it can be dependent on the action or dependent on the character, what it's going to be. Right. I don't even know if I can block copy that. I don't think I can. So, let me just write that down so I can on a notepad. Text file. Right, just so you can see what I'm doing. I must remember it's not Shift 5, 6, 7, 8 to move around in Notepad. And 3. 4, type 5, and then 6, jar, frame, 7, and then CHR, MISC, 8, and then CHR size, 16. Right, I'll save that. That's just for reference. So when we're down in the source, we can then fill in the data. I'll go down to the bottom to do this. Right, character data. And then if I bring that back up, I can make a copy of it here. Actually, I'm just going to put this on a separate screen so I can see it while I'm typing. CHR action, CHR action table, CHR XPOS, YPOS, CHR type, anim, CHR frame. Helps if I spell it correctly. Not that it matters, but CHR MISC and CHR size, but we don't need size because the size is just to tell you how big the data structure is for each one. So, let's tab Shift 3. There we go. Nige, you can see all the fans in the chat log through it though, enjoying the tutorials. Thanks for doing it. You're welcome. It's a pleasure. It's good fun. Right, and if it helps all you guys learn how to make a game, then or learn how to program where you never could before, then even better. That's what the plan of these tutorials is for. Right, so we do db, define byte, and then our action 0 will be nothing for now. And then this will dw, which will be our action table. Actually, we'll call this bad1. It's bad1 action table. Bad1. Right, this way we can have multiple action tables for different baddies, so that you don't have to all use the same actions. Right. What next? XPOS. So where will we have this? We'll start this at string 60, which is just left of the center, and we'll make it at the top. So well, just string 08, so 8 pixels down. And then what we will do is we'll put that as X and Y position. Action table pointer. Right. db type 0, because we only have one type so far, so it's type 0, because 0 is the first number. Type 0. Then we'll have animation 0. and then db0 frame 0, and then we'll have 8 bytes of miscellaneous data. We can use them later for things like boundaries or whatever. You might want to increase 8 bytes to make it more, but for now we'll just have it 8 bytes. Characters db. I'll do it next line. db 1. Right, so obviously we need to do our bad1 action table. This is going to be a jumper table. 2 bits of code, and bad1 stand still. Bad1 stand still, and that will be ret. Nice and easy for now. Right, are you all still following and everything? Because I can't see any comments yet in the Nigel Hirst. I can see all your fans in the chat log. That is the last statement I see. Or last comment I see. Right. So you're still following? Don't need me to slow down. Yep. Okay, all good. Right. Right. What we'll want to do now, just for a quick reference, is at the top of our code. Yeah, Nigel, no worries. No worries, Stuart. Still busy typing. Do you want me to stop anywhere at the data below, or do you want me to? Have you caught up? I can go back before we continue. No go is good. Right. Right. So here we've got a second sprite. What we'll want to do is call draw underscore characters. Are you caught up now? Okay, good. Right. Just Okay. No worry, Tony. I'll try and be quick. But the thing is, sometimes we can't go racing ahead for others. So we've got to draw characters. Right, we're just going to draw characters for the moment, just to get something up on the screen and then show you it working, and then we will go through. Draw characters. Now, what we want to do is load IX, and before people start, oh no, he's using the index registers, they're slow. I'm doing this for a reason, because it makes it easier for when things change, and if you're just getting used to things, so people don't have to worry about speed initially, and plus you're on a next, and it's going to be fast no matter what you do. So we do character load IX with character data, load B, comma, load A, comma, bracket, num underscore characters, load B, comma A. Right, so the reason we can't do load B, comma, brackets num characters, because it's, you can only load from an address with A directly, or with a 16-bit register. You can't do load B, comma, bracket, or load C, comma, bracket. So you have to load it into the A register first, and then load B with A. Right, so, and then for draw characters loop, we'll need to push BC and pop BC, because we'll be putting bits of code in the middle to do our stuff, and then we will add IX, comma. I'm not sure if you can divide the IX with a number directly, so what we'll do is we'll, in fact, we can just do load DE, comma, CHR underscore size, which was 16, and then add IX, comma, DE. And DJNZ, draw characters loop, and then ret. Right. Just for now, as our data isn't really doing much at the moment, we will just get the X and Y position and draw the sprite, draw a sprite. And to do that, with using IX, you can use it as you can use offsets with it, because it's an index register. So we can, although IX is only pointing to the first byte, which is the character action, we can do with IX, comma, CHR underscore XPOS. In fact, we can just load it directly into the E register. D, 0, and D, 32. Load L, actually A, comma, bracket, IX plus CHR underscore YPOS, close bracket, and add A, comma 32, load L with A, and then just for now, we will sort all the extra attributes out for the sprites, but for now, we will set them to 0. Call, add sprite. And then, fingers crossed, hopefully we should get a sprite on the screen. And we're not going to though. Oh yeah, there we go. It worked, hey! Hey Flash, hey Crowley. Glad you can make it. So we now have our sprite up here for our baddie, our first character. Now, the good thing about using the defines for characters, right? I'm going to make a change now. And if we'd have used HL as the pointer to the character data, when I make a change to this, let me get back to the top. Yes, exactly, Pat. Well, I'm going to show you why I'm not doing it with HL at the moment. Because if I change this to 32 now, what's going to happen is the only changes that I need to do, well, I don't actually need to make any changes to make this work. But if I add another character, I will need to make this little change now. And all the change is add another 16 bytes here. Actually, I'll do them in sets of 8. Right, and now we can then do our second character. Right, the reason I'm using the IX register is because we've just changed our structure size, our character size, to 32 bytes now, not 16 bytes. Now, the thing is, if I'd have used HL, I'd have had to change all these bits that I do with IX, because I'd have to add an offset to HL to get HL to point to the XPOS, and then I'd have to inc HL to get to the YPOS, and then I'd have to add character size minus YPOS to get to the next character. And it would just get messy in code, especially if you're making changes like we have just done, or changing your structure size. And that's why it is a lot easier in this case, to use HL instead IX instead of HL. It would just end up being an absolute ball ache, because you can't do load E, comma brackets HL plus CHR underscore XPOS. You can't. That is not a valid instruction, so you can't do that. So it just gets messy, and you need to add more code. It's best to do that on something that is fixed, a fixed structure size and not going to change. And so that's why we're using IX, because it looks a lot neater, tidier, and easier to understand what's going on. Right, so what I want to do is make a quick baddie2, db0, and dw, and we can still use the bad1 action table. Even though it's baddie2, it can still do the same, still have the same actions that the first one can have. which at the moment is just do nothing. Right, so the first one was 20 pixels to the left of center. Now if we go 20 pixels to the right of center for this one, we can have position and then 0, 0, dB 0, and then dB. Actually, I just copy them lines from above. Copy and paste 3 times. There we go. Now, if I save that and assemble and run, we still only have one drawn because the number of characters to handle is 2. Well, it's 1, now it's 2. Now it should work. There we go. Here's our other sprite. Right, so have you all followed that for now? And do you know, is there anything you're not sure about what we've done in the code that we've added for the draw characters? So what we've done is we set up IX for our pointer to the character data, got the number of characters to draw in B, pushed B here, popped B here. We're not changing IX in any code anywhere at the moment, so that's why we didn't push IX. If we do any code in here that modifies IX, we would have to push it and pop it. Then we add character size to go to the next character, and then DJNZ, which decrements B and jumps back if not 0. So decrement and jump if not 0 back to draw loop characters. So does that 2 times, which just gets the X position, adds 32, gets the Y position, adds 32, and sets the other sprite registers to 0 and add sprite. Okay, no worries, Nigel. Yeah, it would be best to catch up with the other tutorials first to get up to date on where we are. So once we've done today's show, if you can try and blitz through all the other tutorials within the next 2 weeks, ready for the next show, that'd be great. If not, you can take a bit longer and hopefully get back up to date on the show after 2 weeks after that. Right, so now what I want to do is I want to make a quick light cycles game, just to get characters moving and stuff. And we'll use the sprites as cursors and everything. What we need to do is I'll do a plot as well for the characters, for the sprites, so when they move, they will. When they move, they'll be leaving a trail behind them. So I'll plot the pixel first. E comment bracket X plus CHR X pos mode D comment bracket X plus CHR score Y pos, and then crawl plot. Was it plot pixel? I can't remember. What did we call the routine? That's right. It's just plot, wasn't it? And you'd have to do push HL and pop HL around all of these as well if you're just doing HL as the pointer to the character data. Right, so that should work. We won't see it because they're not moving yet, but I will test it just to make sure it's okay and doesn't do anything funny. Yep, that's fine. Right, now what we want to do is handle characters. Yep, exactly. And the thing is, you'll find that we're not doing overly much anyway, and we're running at 28 megahertz, so it's going to be absolutely fast enough. You won't even need to worry about optimizing. Right, so we have our push BC, our pop BC, and our load DE, CHR size, add IX, DE, DJ and Z, handle characters loop. Right. Right. I know I've not finished that line, but DW bad one, move down, W bad one, move left, W bad one, move right, W bad one, move up. Actually, I'll make it up and right. So it's down, left, so it goes round in a circle. Yep. Very true, Tony. It's a lot easier to read when it's not optimized. Yeah, that's the whole point of these tutorials. I'm trying to keep it as simple as possible, but giving you the instruction on how to be able to do things yourself when you start taking the code and playing with it. So you basically have an understanding of what each of the instructions are doing. Right, so what we want to do is now call our, see what our action is and jump in the action table. Right, a comma bracket ix plus chr action load L, comma, bracket, ix plus chr. In memory, when you do a DW, it stores, because the Z80 is little endian, it stores the lower byte first and then the higher byte. So you get L with action table, sorry, action underscore table, and then load, drink of water. Throat's getting a bit dry. Load H, comma, bracket, ix plus chr underscore action underscore capitals underscore table plus 1. I'm hoping that the assembler will let me do that. Let me just check that that is valid in this assembler. Okay, I knew that was going to happen. No problem. We will just define them outright. So, and then go back up to the top. Matt has assured me that we'll hopefully have the include files at some point soon, either in the next episode or the episode after, and that will mean that we won't have to keep jumping to scrolling through tons and tons of code to get to the top. Right, duplicate that line. And this will be underscore can't do anything because it's too long. It's no longer 2 bytes, so I can get rid of 2 bytes. 2 bytes long. Into the actions. Low. Points to actions. Right. Right. Lower. Right. 38. Right. Scroll down. Yeah. The error line is only so 256 plus 38. No, must be 512. It's only the low byte in the error line. But anyway, I know where it'll be. It'll be in the call it that, didn't I? 512. It's these. That's what it is. bad one, move down. Right, for now we'll just do a ret because we just need to get it assembled and making, and then we can add the code in a sec. Bad one, move left. Right. Bad one, move up. Right. Bad one, move down. There. Right. Right. Save and assemble. Assembled. Okay. Whew. Right. We should be able to run that too. Yep. Right. Now. Our code to handle it. Right. So at the moment we've just got the A being action and HL being our action table. Right, we want to add HL, A twice because there's 2 bytes in each entry. Then we want to go do load A, brackets HL. Actually, if I do this and change that to a core, use jump table, and then here have a use jump table. We will add HL, add A to HL twice because there's 2 bytes for each value in the jump table. See, because it's a word DW. So that's why we add it twice. 0 will be the first one, 1 will be the second one, and then we want to get the value in HL, load inc HL, and then we want to do load H, HL. We want to do load L, A. Right, and what that does is that we'll get the low byte inc HL to the point to the high byte of the get the high byte into H, because it doesn't matter about HL anymore because that's just pointing to the table, and then sets the low byte with A, which was the first one, because we can't put that in L because it will mess up when we do an incal and get incal HL and the load H, bracket HL if we change the L there, so we have to use the A register as a temporary. Right, and then we just do jump HL. And so when the ret happens in our code, what did I extend 3 goes to the top of the file. Cool. Although I didn't need to be at the top of the file, that is good. I really should find out, not find out, but remember what the keys are for page up and page down rather than just scrolling line by line. Right, so what we're going to do as well is, because we're here, we're going to set up load E, bracket X. And the reason I'm doing this here is because it saves doing it every time in all of the all of the jump table routines. Right, so it will get X and Y pos. So move down. Actually, this should be working. Right, if I assemble it and then run it, and it's not crashing, but that is actually doing the jump to the. Or is it actually? No, it's not. I haven't done handle characters, have I? In the game loop. Or have I? Did I do that? I can't remember. Yeah, load HL, brackets HL would be handy. But the FPGA is getting a bit full, so we want to make sure we finish off the stuff we need to do first, before adding any extra instructions. Yeah, we've got our draw characters there. So but it's usually best to after doing all your drawing of sprites, then do the handle. The reason being is if you get all these drawing stuff done first, it's all done before you get any tear on the screen. Although we're using a delay there, aren't we? Not using the interrupts because we can't use them yet. We will be able to at some point. Just need to get further with the assembler and stuff first. Yeah, it's best not to fake it with SJASM Plus PED because it doesn't say that it affects A register, which it does. All it does is it types in what I did for you when it comes to assembling. Yeah, you can use any of the registers. As Matt said, when you're doing load, where we did the load A, brackets HL. Down to it. And so I save that and then assemble it, run it, and it's not crashing, and that is now calling it. We should be able to do one, and that will be our action for the body going down. Right, so what we can do is inc D, A, D, compare 191. Actually, load brackets IX plus YPOS, and not YPOS, but character YPOS. Right, also I need to tab these out just to make it look a bit neater. Right, and then ret C, and then load right, IX plus IX plus CHR underscore action, comma 2. Right, and then we do E x plus CHR underscore x pos comma, because we want to decrease the x position. What we should really do is actually, yeah, we'll do it a better way so that in case it starts at a position where it's at A comma D, compare 191 yours Z comma bad 1 MD wall. Right. Otherwise inc D, and we can check that one should have been D anyway. And then rep there, and then get rid of that, and then add 1 MD wall, load A comma IX plus CHR underscore YPOS, type, no, action, sorry, action. Now, yeah, I'm gonna and 3 and inc A, and I will explain exactly what this is going to do in a second once I've finished the rest of the thingies, the rest of the actions. A comma E or A instead of compare 0, and then JR Z comma add 1 underscore MD underscore wall, right, and then E, and then ret, and then up will be, oh, sorry, decky E, load A comma D or A JRZ comma bad 1 MD wall, D load brackets IX plus CHR and YPOS comma D. Yeah, it would be a lot easier for me to type on a RealNext keyboard. I'll definitely set it up for next week. But I like the fact that I can do the debugging if there's any issues. Right. And move right, load A comma E, compare 255 JRZ comma bad 1 underscore MD underscore wall. MD was going to be moved down, but because I'm just making the action cycle through them. Right. Then it was inc E load bracket IX plus CHR Y CHR underscore XPOS comma E. Right. Assemble, run, and there we have it. It's going around the screen. Right. Now, now that I've done that, right, this is 1, this is 0, this is 2, 3, and 4. Right. I'm going to write this in English. I'm not going to convert it to BASIC. It's because we're using index registers. It's going to be a bit of a poorly to explain it in basic terms. So get ypos, get character ypos. Because if you remember before the call, or before the call to jump table, we get the X and Y pos in D and E register ready, and because use jump table doesn't change D and E, means it goes straight into the thing with D and E set up as X and Y pos. Right. If compare with 191, if equals 191, then go to bad one and D wall 1. Move down. Move ypos down and then store new ypos. Return. Right. Now this bit is the bit. Get current action. This is with the move. 1 is up. So 1 is down. In brackets there. So right. Best to explain this. Right. What I'm doing, right, so if you come in with 1, if 1, then 3 equals 0, equals 1, then inc A equals 2. Right, so if 2, then and 3 equals 2, then inc A equals 3. If 3, then because this is the 1, and 3 equals 0, then inc A equals 1, and then that puts it back to the first one. I won't do 0 because you already know that that's going to be 1. If 4, then and 3 equals 4. That's not right then, is it? It should be inc 3 then no, and 3 then inc. Yeah, and 3 then inc. Sorry, it's that one that I got wrong. And 3 equals, and 3 equals 3, sorry. Yeah, you're right, and 3 equals 3. I was doing the carry on the wrong one, but it loops round. 4 and 3 equals 0. Then inc A equals 1. And that is what that is doing, the and 3 and the inc A. So it goes from the 1 becomes 2, 2 becomes 3, 3 becomes 4, 4 and 3 is 0, and then inc 1, so it becomes 4. And then store new action. Return. I'm glad they have a nice character, Ped, thank you. You get a free game with every tutorial finish. I did do Manic Miner, actually, on Pac-Man Hardware. Right, bad move left, get Xpos, check with being 0, if 0, go to bad 1 MD wall. You should probably rename that bad 1 MD because it's not moved down anymore, is it? Decrease E to move left. Store new position, new Xpos. Return. Right, and then get YPOS. Check with being 0. If 0, then go to bad 1 MD underscore wall. Then decrease D to move down. To move up, sorry. As 0 is the top left. And then store new YPOS. I shouldn't need to do comments for return anymore because I think you all know what return is and what it does. Get Xpos. Check with being 255. If so, then go to it should be so really, because it's from the competitor, isn't it? Or did it put it up there? If so. Yeah, but Mario wasn't called Mario then, he was called Jumpman in Donkey Kong, so it's kind of not right, even though it was Mario, the character. It was just called Jumpman at that time. Right, increase E to move right. Right. Then store new expos. I won't bother doing that one. Right. Right, let's save that. It should still run because we've not really changed anything. Now what we can do is we should be able to have the other one join in if we change its action to, in fact, we could make the other one move right, which is 2. No, it's not. It's not 2, is it? Right, it's 4. So if we assemble and run, the one on the right is now doing that. Right, so so used to pressing escape to quit out of C-Spect when working on it. F1 dot Odin. Thankfully, plot test as ODS. Thankfully, we save every time, and it also saves F10. Auto saves automatically when you assemble. So should still be where we are. So right now, what I want to do now is do a bit of collision detection. Right, so I'll do call check pixel because we've already got DE set up for the new XY coordinate, and then JR NZ comma 1 underscore MD underscore all. Actually, what I will need to do is what I'll do is I'll make it stop when it yeah, should do it in here or there. Yeah, JR NZ comma right, you're going down, so you can't go back up and you can't go down, so it needs to be try left or right, and then key will be call check pixel, and then JR NZ comma try up or down, and then after the deck D, call check pixel, and then JR NZ, comma, right, left or right. And then after the in key, call check pixel, and then JR NZ, comma, right, up or down. Right. So our check pixel will be pixel add, and then it will be set AE, and then it will be and brackets HL ret, and then try up or down, and will be we've already inked or decked E at this point for the trying up or down, because we've crashed into something moving left or right. So what we want to do now is get the old X position, before you moved, and then I'm going to use the reg for the moment, and then and for JRZ, comma, try up, and then try down. So try up, try down will be ink D, and then actually we won't. We'll check to make sure it's not off screen first. D or A JRZ, comma, try A or A, compare 191, try up, and then what we'll do is ink D, then call check pixel, JR actually ink D load bracket IX plus CHR Y pos, comma A, right, not HD. Nope. Right, and then ret Z. So if it's clear to do so, it's okay. Then if it's not clear, deck D, call check pixel, Yeah, check. I'm gonna have to do the checks both sides on the down, the up as well, because we need to. If this fails, right, set, right. So at this point, we're trying down. So we want to do load ix plus chr underscore action, comma, what is the order? Like, we will make a add down, move down equal a EQU1, move underscore left T, EQU2, move underscore up EQU3, move underscore right EQU4. Right. Move down. Move underscore right. Right, the reason I'm doing that is so I can just set the directions when we do our collision. So move underscore down, and then move load ix plus chr underscore action, comma, move underscore up. Right. And then if that fails, just do load. Actually, if I get rid of that line and copy that line, paste that line there, then we can just go to the end and set to 0, and that will make it stop. Right. Then try up will be load A, comma D, or A, JR, Z, comma, try down. Because otherwise, if it did a collision on try up, and if it failed, instead of doing our extra deck D, what we do is if we did jump to try up, we'd end up going around in a loop when you crash and it lock up the machine. So that's why I'm doing this. Right, and there's some questions about load A, comma R. Right. Extend up and down, will page up and down. Right, is that? Yeah, okay. Thank you, Matt. I shall remember that. R is a magic register. It's the refresh register. It just basically for refreshing the RAM, and you don't need to worry about it because we're using different RAMs now anyway. Not that you need to worry about touching it anyway, but it's just like a not very random. because it just keeps incrementing, and it's ended with 127, so it never sets bit 8. It never sets bit 7. Sorry. It's never gets to 128. It just goes back to 0. And so in the code, because I don't know what that number will be, I just get the small. I can get the cursor back from thingy. Introduced a bug where, Matteo? Few rows above where? Which line? Yeah, our register's like a really rudimentary, basic random number generator. If you can't be asked doing a more complex one, and it's only one instruction, so it's quick if it doesn't need to be random as such. I mean, it might turn out that we need to make it more random, and then we'll do a call get rand in there. But for the moment, I'm just doing load A with R because it's quicker. Off the top of the screen, right? Tell me which function it's in. Above the and for. Where's the bug? After load E, ix plus. Where? 9636. Load A, R. Try up or down. This one. A line above, try down. No. JRZ, come and try up. Why is... No, it should be load A, R, because it's a like a random number. I'm using it as a random number generator because I'm trying up or down. I'm picking a no, it shouldn't be a load A with E. It's load A with R because I'm using it as a random number generator to decide left or right. No, up or down. Decide up or down. If bit 2 is 0, try up. Yeah, no worries. Well, I'm glad you you asked it. I mean, I was going to go through when I come to comment it, but soon. But I was just trying to get the code in and working, and then I'll go through, make sure. Well, I'll run it, make sure it works, and then when it works, I'll comment it, and go through and explain what I've been doing. But it's just a quick, easy random routine. Load A with R. It's not very random, but if it doesn't need to be exactly random, which for this example we don't. It's just for speed. I've just used load A with R instead of having to create a random number generator because we haven't got one in this setup at the moment. Right, and then we want to do deckd load bracket ix plus chr underscore ypos close comma d load x plus chr underscore action comma move underscore up, and then call check pixel ret z, and then inc d, and then load x plus and chr underscore action comma move underscore down, call check pixel ret z, jr set dead. Right, so that's try up and try down. Now we need try left or right. Try left or right. Load. Underscore ypos. Right. I'm just going to comment this before I forget why we do this at the beginning. We've 7. We've already moved in Y and hit wall. So restoring a previous Y position. Right. And that's the same with A on the for the X position. Hit wall, so restore previous X position. Right. Load A comma R and 4 z comma and try right. Actually, try left. That's the same as up. Because let me try right is load A comma E CP 255 in. I was going to say we can't do an in K. So Z comma try left. Deck. Sorry, inc E. Load brackets AX plus CHR underscore XPOS comma E. Load AX plus CHR underscore action comma move right RT, and then the check pixel. Check pixel ret Z, deck E, load, brackets, X plus, chart underscore action, comma, move left, and call check pixel, ret Z, JR, set dead, and try up, load A, comma E, click up, left, or A, ret Z, and deck E, brackets X plus CHR underscore X pos, comma E, and load bracket X plus CHR underscore action, comma, move underscore left, call check pixel Z, ink E, load brackets IX plus CHR underscore in close, comma, move underscore right, call check pixel ret Z, set dead. Right. Fingers crossed. Is this going to work? Is it going to assemble? Who knows? It's assembled. It died because it's not, it didn't move up. Right, okay. Oh, press escape. Oh, just as well we save. I'll just inspect again. Control F1, space, dot, Odin, F10, load, plot test dot ODS. Right. Right. Sorry, if we assemble and run. Right. That one. Run it again. No, assemble and run because we need to reset the values in the character data. Right. So it's dying when it right. Where are we? Right. Bird move left. Right. So That bit's working, that bit's working. Right, yeah. So, there's comments, just check where we're up to. Yeah, it does stick. That's what I'm just trying to work out, Nigel. If I shift 1, no, F10, shift, if I use the right screen, right, assemble it and run it again. Right, follow the left one. Right, that was moving right, and then it goes up and dies. So on the try right, no, move right. So it increases the position, checks the pixel. If it's not 0, if it's set, then try up or down. Try up or down. Where's try up or down? Try up or down. Gets the old X position. Decides whether to go up. Trying up because it crashes going up. And we'll do with D or a Z. Try down. Right. This one's moving right. Hits the wall. Checks up. Goes to try up at O, D or A. We're on line. Actually, what line are we on? In fact, what we can do is we can show our data because we already have debug stuff in, don't we? So if we go back near the top, let me get up a lot quicker. Yes. Thank you, Matt. Right, where's the text? Where is our text? Where are you? Yeah, here it is. Right. So we need to do db pr. Let's come out 0, come out 48, come out pr deck 8, dw. Actually, if I scroll down and it is P1X. P2X. There we are. X16. X16. Did it do hex? Back down again. Print. Where are you? Deck. Oh, I've only got deck. Right, okay. It's getting late, and I won't add the hex bit. I shall add hex next episode. I should really try and finish this up for this week. Deck 8, and then X DB deck 8 quote comma and DW P1X plus 1, and that should be P1Y. Yeah, we'll just do the just do the phase player. Save that. Assemble and run. Right, so we've got phase player. Right, he's at 97,93. 97,3. So he's not at the top of the screen. So that's not an issue, right? He is dying. Right. So try to move right. So empty wall, ink E. Did he hit a wall before the thingy? Right, what I'm going to do is going to draw a wall around the game initially at the start. Load D, 0, call plot, load D, 191, call plot. Actually, load E, 0. Box loop. Right. Load D, E, load E, 0, call plot, load E, 255, call plot, and then load E, D, load ink E, JRNZ, box loop. Right, and that will print a box around the screen, and we've got checks to make sure it doesn't plot off the bottom of the screen in the plot routine, so that should be safe. So save that, exit, assemble, and run. Ah, that's interesting. Right. So I can get rid of those checks for on the try up and try down, try left and try right, because we know that it should never get there because it will be on this it would have hit a pixel, but hit a wall because we put a wall around the whole of the X. Because we put a wall around it. Right. X. And that way. Right, I've just deleted the checks for the border because we put a border on anyway, because we're going to need the border for the player when the player starts joining in. Right, so when we are moving right, we want to try up or down. So first of all, get the old X position, and we get a bit to see whether of the R register to see if it to go up, try up or down. Try down. On the crash, it's usually on the up. So say we try up, we then decrease D. So if you're going right, you go into 255, you hit a wall, goes back to 254, and then it decks D possibly to 0. Check pixel and ret Z. That will be a 1 because it's a thingy, so it won't. So inc D to 1 and inc D to 2, and then check pixel. If it's clear, then it'll just retain because it's set to moving down. Otherwise, it's set to dead. Pixel set it in. Yeah. That. Right, let's see if I can get it to. So that's gone down and attempted to go right. Well, that one's gone from 190. That's gone down into a line that's already there. So why is that not? Right, so it was moving left. So we do bad move left. Load A with E, or A, jump Z, which is not. In fact, I don't need these either because because we've put the border in. So I can do it on the check pixel. Right, so let's try that now, because I think that I have a sneaking suspicion that might have had something to do with it. No, it hasn't. At least they've both done it on moving right. Going up and turning right. So on move up, select D, it's hit a wall, and Z, try left or right. Try left or right, get the Y position, which should be one down, because we just done the move up, which is the deck E. Let's try right, it's got, well, try left or right, get our old position. It's trying right in key, word X pause with E, and move right with setting the action to move right. Call check position, and if it's clear, Z. But it isn't clear because it's not written. Oh, it isn't clear. So it should come through. Decky, which is what we wanted to do. There we go. Need to set the position, don't we? That's what it is. Right, and need to do that for all the other bits now. So try left. That's what it is. That's definitely what it is, because it's not setting the actual position, so it's going back to the old position, and then next time through the loop it finds that the pixel has been set. So it then can't move any direction, and that's why it dies. So I'm pretty much guarantee it is this. Hey! And then that will keep going and going and going until it fills in. Yep. Just checked. Well done, Corsibat. You spotted it as well. And so, yeah, that should keep going until it thingies, but we'll stop it because we know it's going to fill the screen. As exciting as it is to watch, we will sort of finish up because it's getting late. Right, so is everyone up to date with the code? Root indeed, Corsibat. Root indeed. Right. Right. Where was I was doing? Yeah, I need to. We can now remove that character that we were just scrolling across the screen, because that's not needed in this game. Where are we? Where are we? this Xpos 2. This one. We do not need that one. We do not need that. Now we can get rid of this extra debug stuff because we don't need that because we fixed our issue. And we can comment these out because we're going to be finishing the game off next week, and we don't want stuff on the screen causing like things to crash into. Right. Also, we'll next week as well. We'll add some sprites for the bikes and which way they're going, etc. Where are we? Right, I shall just comment through this. Sets ix to point to character data and gets the num characters into a reg. Copies that to B for our DJNZ. Pushes BC to the stack so we can use it if we want to. What we do for the drawing of the sprite, as you can see at the bottom of the line here, or bottom of the screen, that alters the B register. So that's why we push it. Get the characters Xpos in E. Get the characters YPOS in D. Do a plot, or should I say, call the plot function, not function, routine. Mike Daly, if you're watching this, can you do me the big favor? Can you make the like if you press delete, can you make it like release the caps, or keep the caps if you've got the like? So if I hold cap shift, well, if I hold shift, I can type in capitals. If I still keep hold of shift and press delete, it deletes, as you would imagine so. But then if I keep hold of shift without letting go from the start, then it types in lowercase. Any chance you can fix that for us, mate? That would be awesome if you can do that. Right. Yeah, another drink of water actually. Get the characters. I don't need to do this because the plot doesn't change the E register. So this D and E should still be the X and Y pos, but we do need to change D to 0 there. I mean, I could do a load A, comma D, and then add A, comma 32, and load E, comma A, load L, comma A there, and then load D with 0. But that's getting into like optimization things, and the code's going out of order. It's just easier to do it, show it as one thing at a time, one step at a time, rather than into weaving code instructions. Clear the white of DE. And add 32 to DE. Get characters Y pos in D in A. And 32 to A. Bring it down from the border. But you know why I'm adding 32 to the X and the Y, don't you, with the sprites, because it sets the offset so that it's on screen. And 0, 0 in our char X pos and char Y pos is the top left pixel of the ULA screen, which is 32 in the X and 32 in the Y. That's why we add the 32 to the X and Y. Store that in L for our add sprite. Let's see what is C for our add sprite. It's sprite image and the flips. Yeah. Clear set sprite image. That we'll be setting that up later. Next episode. Set sprite flip bits. Since we won't be affecting the palette in the flip bits because we're using 256 color sprites. Right. And what was H? The extra bits. Clear extra bits for sprite. What are the extra bits? In the attributes register. Yeah, it's the attributes. Which, if you look in the manual, it will tell you. Right. Call sprite. Pop BC from the stack, so we can loop around. So we can DJ and Z. Actually, I'll just num characters. I will not put the brackets in there. No, it's on the screen then. It's set D to CHR underscore size. add D to IX, moving IX to our next character, CHAR will do, and then dec B and jump relative not 0, draw characters loop. You know what this is. That one? Yeah. Right. And the characters. Set IX to character data. Actually, yeah. Get characters in A. Copy class to B for DJ and Z. Star BC on the stack. Get CHR X pos in E. Get CHR underscore Y pos in D. Get CHR underscore action in A. Get a byte of star action table. Get a byte of character table, character action table. Use the jump table. Store BC on the stack. That's restore as in English restore, not the basic restore. Set D to CHR underscore size. Add it to X to point to next character. DJN's loop around until all characters done. Yep, you guessed it. Return. Right. Right. Use jump table entry with A equals index and HL equals jump table. Add A to HL. Add A to HL. We add this twice. because the jump table is 2 bytes per jump, not per address. Get the low byte in A, in KHL to point to high byte. Get the high byte in H. Set L to A, low byte. And then go to HL. Don't need comments on the data, and this is all not all commented yet. Right. Call check pixel. If hit pixel, go to try up or down. Right. Call check pixel. If hit pixel, go to try left or right. Call check pixel. If hit pixel, go to try up or down. Convert D to quads D into pixel address HL. Set A to equivalent pixel for ULA. And with ULA to see if hit pixel, return. This sets the Z flag with sets the Z flag will do, and that's what is read when you do the JRNZ and JRZ. So if the flag is set, then it on the JRZ it will jump. If the Z flag is not set on the JRNZ, it will jump. Otherwise, it won't on the JRZ. It won't do the jump. It just skip to the next instruction. Right. This one, the one that caused a bit of confusion. Get R register into A. R is an internal 7-bit counter. So it's just constantly counting up while your instructions are going through. R is increasing. So it's like a random number generator. test bit 2 of our random number. Our basic random number. If bit is clear, 0, then go to try left. Otherwise it falls into try right, and then we increase x, not e, which is our x position. Store e in xpos. Set action to move right. Call check pixel at new chord. If no pixel, we're good to return. Otherwise, we've hit a pixel. Checking right. Otherwise, decrease E twice, because that's the first position, which is our last position, and then because we increased it there, so we decrease it, takes it back to the original, and then decrease it again, moves left. And 3. I'll take back to the original place, no, to previous place. To previous place, that's better. The key moves chords to left. Set x. Set xpos. Set action to move left. Cool. Check pixel. That's new chord. If no pixel, only put them in because I can. I was going to leave them, and I'll change this to move. Right. Otherwise, we've hit a wall going forward, and then we've hit a wall turning or left or right. Right. Try left. E. And set new xpos. Set new action to move left. Check pixel as new chord. Oh, what is going on here? Matt, did you see that? Matt, are you there still? Matt, are you seeing what's happening? Are you there, Matt? Hello, Matt, are you there? Anybody there? Can't see any messages coming through. Let me just see if I can. Can somebody message to see if there's. Let's make sure I can actually see something. I don't friendless, so spam alerts him. Oh, you're there. Right. Good. You hear me? That was a long delay. Right. Is Matt here? Matt Davies. Are you still here, Matt? Yeah, it's calling Matt. Come in. Are you there? I'm guessing not. Right. I don't know if you guys can see this, but when I'm scrolling down, different lines are coming up. Oh, yeah, to dash. Okay, right. Right, let me. Okay. Something is definitely not right here. I don't know whether yeah. I'm not going to save this. I wonder if the file size is too big. Mind you, know, said I've got 64K for the source. Let me just check to see what size. Plot test. Is that 15K last time I saved? And I've typed in a load of comments. Yeah, that's what I'm thinking. I don't want to save it again, because if I save or assemble or anything, it could actually. Hang on, let me see if I can copy that back to there. Right, so I've got a copy of that anyway now. Right, if I page up to the top of the file and then page down. No, it's dead. Yeah, I'm glad I didn't do anything. Right, oof. I think we might have to call it a day. All that typing's caused it to crash. Okay. Hopefully you will have saved things at the same point as I have. Oh, you're back, Matt. Yeah, I could save it as a different name, couldn't I? Save light cycles.ods. Can you have more than 8 letters? You can, can't you? To next. Right. Be sure it's definitely got 48K and not just 16K. All right, okay. So should I send this file to you to have a look at? See if we can find out what it is. Yeah. Yep, that's what I was thinking. So what I will do is send this to you. Thankfully, the version that I've saved and backed up is worked the last time I ran it, which it would have saved and ran. Yep, okay, right. We'll do that then. We'll call it a day for now. I can't even go back and show the code and everything. So what I will do is next weekend we'll continue with this from wherever it is that Matt can get it to, whether it's we go back to the other one and I remove all the comments, all the old comments, and just put in the new comments, or whether, yeah, no worries about it. We know it's experimental anyway, Matt, so the fact it's got a bug in isn't an issue at all. Don't worry at all ever if there's a bug in Odin, because it shouldn't even be out yet, and it's only out because you've allowed it to be out in this very early stage. So yeah, Stuart, was your game will be the same as mine anyway. So what I'll do is when next Sunday, instead of waiting 2 Sundays, we'll do it next Sunday. When we get it sorted, hopefully it'll be before Sunday, I'll put the file on Facebook, and then you'll be able to grab it then. I'll put it in the Spectrum Next group, and you can grab it. Exactly. It's an early test Q&A department. Yeah, this one's a bit of a biggie. It's but it's not in the sense that we've only been typing in comments, so there's no loss of anything really. Yep, I'm Matt's QA bitch, so I shall test things for him. Exactly, it's the perils of coding in real time with beta. Well, it's not even alpha. It's pre-alpha, let alone beta or final version. Yeah. Okay, cool, Richard. Thank you. Yeah, it's any lost comments, so it's not too bad. So yeah, no worries there. Has anyone got any questions on what we've done today? Were they following it okay? Yeah, bug hunting while trying to keep up typing. Has anyone got any questions? Or we got to wind up? No worries, Gaz. Always a pleasure. Yep, no worries, Retro Robbins. See you next week. Next week, don't forget, not in 2 weeks. It's next week. We'll finish off this one. Yeah. Yeah, Nigel. It would be best to look at the earlier videos as well. If you have any questions, Nigel, while you're going through the earlier videos, just message me on Facebook. Or wait till next weekend or whatever. Message when we're on live, when you catch up next time. Gave you a C. No worries, Retro Robin. See you next week. It's been emotional. Yeah, no worries, Nige. See you later. Bye, Crowley. Yeah, cheers for that, Matt. Anytime, Nigel. Right, I will finish up if no one has any questions. I hope you enjoyed the show today. Yep, no worries, Richard. That's why I thought I'd use the IX, and you can see the fact that because we're using the IX Plus and then the index, like the char XPOS and char YPOS, it helps you know what the code's doing and stuff like that, rather than just IX plus 0 or IX plus 1 and stuff. So it comes in handy. No worries, Richard. I'm enjoying doing these, and I'm glad that other people are enjoying them. And if it helps people learn, then that's the whole point of this. See you, Matthew. Yeah, plus 127 and minus 128 is the offsets for the IX Plus. Right, I shall call it a day and close up. Have a good one, guys. See you next weekend. Or on Facebook if you want to message during the week. Have a good weekend. What's left of it. Ta-ra.